You're listening to the Future Tech Health Podcast with Richard Jacobs. Until I reached age 40, I never realized the obvious, that we all have medical issues, or we at least have a family member or close relation that has, or will have them in the future. Medicine and biological systems are the final frontier. Until we've conquered death, figured out how life began, cured cancer, and understood our purpose in the universe, there's a heck of a lot to talk about when it comes to our health. Future Tech Health means I'll be covering futuristic topics that are actually already in clinical trials, or even starting to appear on shelves or by prescription, or available for your own use. We dive deep into stem cells, CRISPR-Cas9, the science of sleep, epigenetics, medical testing, cancer, ketogenic diets, stem cells, aging, regenerative medicine, and more. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a serious medical problem. Remember, however, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you enjoy the podcast, please listen, subscribe, like, and share it with friends. Thank you. Hello, this is Richard Jacobs with the Future Tech and Future Tech Health podcast. My guest today is Jafar Noori. He's the head of a new project. The company's called Intelligent Pollutant Monitoring, IPM. So Jafar, thanks for coming. How are you doing today?
How are you doing, Richard?
Good. Tell me, sounds very interesting. What's Intelligent Pollution Monitoring about?
Yes. So IPM is a startup company. We started back in 2014 with a scope to measure chemicals in water, toxic chemicals that can do harm to your health. So drinking water is something that's like you need to consume water all the time. And if it's not safe enough, then you will end up in health issues, or you end up having health problems. And so we started this company on the base to have a device that can give you continuous measurements on the quality of the water that you are drinking in your house. Of course, what we are developing is something that not you as a consumer, an individual consumer will use, but the water producer or the municipality can use to secure the area.
Oh, okay. So it's not for individual consumers; it's for the municipality itself.
Yes.
I thought that our drinking water is this in the U.S. or is it in other countries?
Well, we are based in Denmark, but we have been engaged in international markets so far. I have just actually came back from the States. I was presenting the latest results that we have in Texas 2 weeks ago. So we are focusing actually on international market and trying to penetrate into the U.S. market as well.
Oh, it doesn't seem like, I don't know, but then I'm only in one place.
Yes.
It doesn't seem like we have many water quality issues with the water treatment plants here in the U.S., but is that not true?
Yeah, it depends on how you see it, because how I started the company, I was sitting in one of the lectures, and the lecturer asked a question: what do you know about like the water quality? How frequent do you think they are measuring? And everyone was thinking in the room, it's every day. And then the answer was like, in some locations, it's up to every second year they can measure certain chemicals. So, especially like these pesticides and nitrate, they are specific chemicals that can really do harms to your body. And the effect, it will not be like tomorrow. You will see it within 10 or 20 years when someone catches the cancer, then there is a problem. And this is one of the causes. So, of course, maybe you don't see it in the US. Maybe it hasn't been reported. But for example, in Denmark, for the past year, we have been having incidents and reports coming into the media about different pesticides that has been banned in the 60s. Now it's appearing. So one of the villages, actually, north in Copenhagen, they have been banned from drinking water from the tap, and not even to brush their teeth with the water because it's highly contaminated with pesticide. So it depends on where you are.
Yeah, that's great. I thought in water treatment plants, they're sampling the water continuously and taking out certain contaminants, and they don't even release the water unless it meets certain standards.
But that's what I was saying. Like it's up to like sometimes in some locations it's not that frequent because the current technology, it's time consuming. It's like it needs resources. So basically, you take a bottle, you sample, and you send it to a laboratory. After 5 days, you get a result. And that needs a highly trained personnel, and it needs the central laboratory, and it needs resources in order for you to do continuous measurements. So they don't do it that frequent. It depends again on your location. So if they know there is a huge problem in your area, so maybe they will sample a little bit frequent. But if they are assuming there is no problem, then it will continue to this low frequency.
Oh, that's crazy. How could they say that they're protecting public health if they're only sampling things, every week, every month, every year?
Yes.
I mean,
It
makes no sense.
Yes, and that's why incidents now have been reported in at least in my country, and that's the media that I'm following at the moment. But we know, like across Europe, there has been several reports. We are trying to follow that as well, trying to see if there is like incidents, some cases where like the pesticide is increasing without anybody noticing that, and we are trying to develop the device, deliver it to the customers, hopefully by the end of this year, so we can avoid such things.
So, how would old pesticides show up in a water supply? How do you think that happens?
Well, most of the water comes either from like our fresh water comes either from rivers or groundwater. So the pesticide is sitting in the like binded to the soil and start leaching slowly to the groundwater level. And then when it reaches that or it reaches the river, then it starts to appear. It doesn't degrade very fast. So it stays there for years, many, many years. The lifetime is very long. And then once it's there, it will just flow with the water flow, and then it will appear in your pipe or in the production unit that you have. And that's why you see it in drinking water.
Don't we have UV radiation or ways to safely irradiate water to break up a lot of these pollutants or use sunlight? Or
the radiation will not do so. Activated carbon might help in some places, but like simple filtration and aeration, like the simple procedures will not work, and UV or like aeration will also not help in that matter. For example, if you look in, I don't know where you like, depends on your location. So in many areas they spray this Roundup, glyphosate, and that's has been reported to be harmless. It depends on who you ask, but this compound has been used intensively. So and at some point it will reach the groundwater or it will reach the surface water, and definitely it will end up in our tap water. So if you drink that in one way or another, you will get cancer because you are like consuming even low quantities, but in a continuous exposure, that definitely will have health problem.
What about bottled water in different countries in the U.S. and the place? Is that better, worse, same? Do they test it more for chemicals?
Well, that is something different because it's a manufacturing, it's a facility, so they need to control it even more. So it's a bit better, I would say, I would assume to that. But again, you never know until you do this frequent testing, because in some locations, let's take this example. It's let's say it's every second year. So you measure today, and you go in 2 years' time, and you measure again. So what happened between these 2 years, you don't know. So maybe there is like a spike of contamination going through, where you keep pumping to the customers. They keep consuming high concentrations of chemicals, toxicants, and then it passes away. And then you sample again, and you see, okay, within this 2 years interval, there was nothing. So we will keep doing the interval. But in a factory, I think they will do it more frequent, or at least they will check it a little bit more frequent, because that follow a different rules or different regulations. It's more like production facility than water treatment.
Yeah, that's pretty insane. So do the water municipalities even want to sample more?
Yes.
Do they have the technology to fix it if it's sampled,
yes.
or do they not want to sample?
They would like to sample more, and actually now we started engaging more with the water producers, especially here in Denmark. They are actually trying to get more and more, but the technology today is very limited. So when we started back in 2014, the technology was not ready. We had to invent something in order to get it ready to the level that can be installed in the field and give you this continuous measurements. So back in 2014, there was nothing. And when we started actually presenting the idea, just an idea, everyone was saying that that's not going to work. You're just a dreamer and you have a vision that will never work. But now we started seeing results. We have been testing in real samples from different countries. We get different waters send it to us to the laboratory to test, just to double check our prototype before we release it to the market. And it seems like it's actually working. and the customers are ready to install it in there and just get feedback. So when installing and when measuring, then you will avoid actually huge fines from the municipalities. If you are sending contaminated water, then you will get a fine because you are damaging an end consumer, and you could also avoid closure, because if you know that the concentration is slowly increasing in your well or in your uh, like pumping point, then you could react fast, apply a cleaning solution, again such as activated carbon, and that will help you keep the production in place instead of like shut down or lose your business. So they are also looking forward to that.
So is this going to be, in situ, and you're going to be continuously monitoring the water, or does it still have to be sampled and taken to a lab?
So what we deliver a device that has sensors. It's already designed to detect certain chemicals. So one of the main chemicals that we are focusing on is this pesticide called Roundup or glyphosate. That's one of the main chemicals. So we have sensors, and inside that tube, we have also electronics that operate the sensors, and it's communicating through antenna, so GSM module. And then while you are sitting at your office, you get a continuous readings. You program the device to the frequency of sampling. You can do a frequency from milliseconds up to a few days. So it's up to you as a producer. If you'd like to show the public more data to show how safe you are, then you can program it to measure every millisecond. But it will be like in situ. You install it once and you service it once a year.
But again, right now it seems like the standards are so lax. That's why you have municipalities sampling every 2 years. What's the standard once you have this equipment? What's useful?
Well, then we need. That's actually we have been in discussion with certain people in here. Regulatories, they are saying we need to compare it to the standards, so to the laboratory, the certified laboratories, and show that we can match the results, and then we could be the next standard. So the water.
Well, when I say standard, I mean how frequent. Is there a frequency standard right now?
Again, it depends. So if your area is proven to be contaminated or highly contamination, or there is a historic site where we know it has been contaminated, then they will force you to do a very frequent sampling. So maybe once a week or once every second week. But if you are in an area where it hasn't been reported as there is a toxicant in there, then it will be relaxed, like every year, every 6 months, every 2 years. Nobody knows. It depends on the area.
Okay. So what have you noticed when you've done some continuous monitoring? Do you see any patterns or interesting data?
Well, so far we are trying to assemble the device as a prototype. We didn't reach a point where the customer is testing it yet, but we are trying to reach that point. So we are launching the product by end of this year, trying to hand it over to customers, and then based on that we will have more findings on how we'll try to link it to the rainfall, the water flow, and different things. But so far we are in developing stage.
Well, what challenges are you facing right now? What's making it hard to do this?
Well, the biggest two challenges that we have faced. One of them, back in the days when we started introducing the product, even the waterworks or the water producers, they weren't so happy about measuring frequently, because they are saying, if we will know about what's in the water, then we will be forced actually to do a cleaning procedure. For example, in Europe, we have this hot list of 10 or 20 chemicals that you need to measure, and they don't want to measure more than that. So they didn't want to go out of this safe cocoon or safe bubble that they have around themselves. But the public awareness increase, and people asking for what is in the water. So now the water producers are asking for more. So that was one challenge, shifting the water producers from one mindset of sampling not that frequent to a continuous online, something that will give you more data and more secure. And the second thing, actually, to convince the funding agencies to fund the project. That was a little bit rough, but we managed to go through, to penetrate that.
Well, which pollutants are being sampled even rarely, and which ones do governments want to sample? Is there any difference there?
Well, again, it depends from country to country. In Europe, we have a certain regulation. So pesticides, it's sampled, and they have certain list of pesticides. And we have a certain detection limit. So if you exceed 0.1 microgram per liter, then you need to stop production. In the US, it's a little bit different. So each pesticide is sitting or a group of pesticides is sitting in a certain category. And then, like, for example, I know Group E has a detection limit of 700 microgram per liter. If you exceed that, then you need to stop production. So it depends, again, from country to country. We have in the Europe, the nitrate is one of the elements that we have to measure. It's a must. And there is a directive regulating the concentrations and how do you react if you get this chemical into your water. But again,
what are some of the big pollutants, and what are some of the effects of them? You mentioned glyphosate, which is Roundup,
yes,
as being cancerous. What about nitrates, and what are some other ones, and what would be the effects of these pollutants?
In nitrate, it has more effects on baby, as far as I remember. It do blue baby syndromes, so it has some other effects. But pesticides is more like when we do work in the lab and we get the safety data sheet. It's more into carcinogenic material. So if you get exposed to it in a very frequent base, then there is a high risk that you will get a cancer in one place of your body. And imagine if the root of exposure is actually the drinking water that, like, I don't know how frequent, for example, you yourself as a person drink, but like 10, 20 glasses that contain certain concentration of pesticides in, and you get exposed to that every day, then you will definitely get something that is not good.
Yeah, that's crazy.
Yes.
Hey, have you done a study, or have you seen studies on the top worst pollutants that, I know it depends on country, but are there any in common that every country is worried about, or most countries are worried about most of all?
I think it's more generic, like across the globe. So once we get a study saying compound X or compound Y is toxic, for example, DDT, nobody on the planet, I think, using it now, because they started banned it one after another. So once you see it's carcinogenic, it has been proven by studies, then countries will be banning it one after another, because you don't want to be exposed to it.
What about countries that don't have a lot of money and they're just lucky to have water treatment at all? Are you working on a solution for them? A low-cost one, or what should we do?
Yes, we have heard actually some of the countries in some of the news, they take other countries as a model. So let's take country X. If they say Europe is still using this chemical, so because Europe is using it, it means it's safe, and we will keep using it the same way. And they will not monitor the water, like third world country, or they don't care, because they take the modern countries as an example, and they will just follow. So whatever you do, it will affect them as well, if you know what I mean.
Yeah, the poorer countries, again,
Yes.
barely have any money to even treat the water at all.
Exactly.
So I don't know if it seems like they would never go for this kind of thing until they're at a stage where they have quite a bit more money. But okay.
Well, it depends. Like, we are not offering it at a very high price. We are trying to match the requirement, because again, it's my health, your health, and everybody's health. So we don't want to make a huge profit out of it, but we would like to also secure the health, the public health, all the time. We try to get as much data as we can in order to avoid a crisis or a situation where we'll end up having no clean water in the tap to drink. So I think even poor country that has been using pesticides. So some of the countries, poor countries, if they don't pour pesticides in their land, then they shouldn't have this problem. They will have more problems with biological materials, for example, biological contamination with bacteria, most likely, because they have a cracky system, or bacteria can leak into the tap water. So, but in countries where we have a huge agricultural fields, and in these fields we spray a lot of fertilizers, a lot of pesticides in order to maximize the yield growth of the crops, then you have this problem. So it depends on where you are and which kind of industry your country is running.
Why not couple this sensor with sensors that some people can have in their homes, so you can not only see what the continuous monitoring does, but downstream you could see if that changes and how that changes in people's homes?
We have been actually discussing that with the water producers, and they would like to propose a different model. So, for example, in some countries, they apply chlorine or fluorine to enhance the water, or to avoid contamination, like biological contamination. And they would like to see, if we apply a concentration X at the production unit, how much is actually reaching the customer? Does this chlorine or fluorine degrade along the way? So that's something that we are also thinking, and we are trying to build a sensor for that. so it can meet that other requirement. But you should actually centralize, make sure that the water that you are distributing in the distribution network is something clean, and you clear it in the facility before releasing it to the end users, to the individuals. Because as a person, if I measure pesticide and I see high concentrations of pesticide, what can I do? Like, there is no like easy treatment in-house. It should be like more chemical treatment in a central unit.
You could avoid drinking the water. You could do that and go to bottled water, maybe.
Of course, that could be an option as well. Yes, that's for sure.
I mean, there's different levels. You could say, okay, there's pesticides in my water. I'm going to bathe in it. I'm just not going to drink it, but I'll still be able to bathe in it, let's say. Or maybe I can boil the water, only drink it boiled, and maybe that will still be okay for me, maybe not. I don't know. But at least you can have different levels of use of your own water, and you'd be informed instead of blind.
Yeah, that's also an option. But again, if we install the individual, then we could also cause a public panic. So the waterworks are forced to publish their data all the time. So you will, as an individual, have access to this data all the time, and you can have the readings. If the waterwork, of course, allow and publish it. It depends on the regulation in that area. But then you can just read the report instead of having like you calling your neighbor, causing a public panic, and then end up in a bad situation. Of course.
Well, example, I mean, there's different ways to monetize it. You could be part of a test group. The water treatment plant could say, for an additional fee, or you could pay for an additional fee to have this stuff installed in your home.
Yes.
I mean, there's many ways to go about it, it seems like,
Of course. But the most interesting way for individuals, because we also run a survey, you tell them about the pesticides and the chemicals, they are more and more interested in biological contamination. Because if you get E. coli in the water, that's an immediate effect that you will see it like after you consume the water. Then you might get a diarrhea or something, and then you need to rush to the hospital. And that's something that no one would like to have. So you get some sort of a food poisoning, and that's what you can measure instead of waiting for like the municipality or something to release a press or call you and say don't drink the water. So they are more interested in biological materials as an individuals.
All right. So what are some of the difficulties? Is it pretty hard to make sensors that can test for all these things? I mean, do you have to have an array of sensors, each one that tests for only certain components? And what's your difficulty in doing this? What's making it hard?
Well, each sensor needs to be designed specifically to identify and quantify a certain pesticide. So we have a sensor designed specifically to measure Roundup and Glyphosate. We have another sensor that is designed to measure another pesticide called pentazone. We have another sensor like to measure AMPA. So we need to have an array of sensors. And each sensor, to design it, we need to study it for a couple of months. We need to study the chemical structure of the pesticide of interest. We need to see actually if there's a contamination incidence, if it's market relevant. And then we start developing the software around it, the library, and implement it in the final product. Once we have that, it's just like with a push a button, we modify the device. We send you the sensor like with an envelope. You can just, as a water producer, install the new sensor in your device, modify your device, and you can measure extra chemical. But it's actually within the R&D itself, it's a little bit difficult because you need to find this unique fingerprint for each pesticide to say this pesticide has this amount or like this unique fingerprint.
What if you had to do it in stages? What if you were able to put some kind of binding agent? Let's say water treatment plant, you divert a very small part of the stream. You put a binding agent in the water, which is not very specific. It binds up a whole class of organic compounds, and then at least you maybe can get an initial signal that one of many pesticides could be there, and then you could decide whether to take it to the next level and analyze that. Maybe that's a path. Just an idea.
Yeah, like each pesticide has a very unique molecule structure. So even a binder will not be easy to implement because like it can bind to a molecule 1 and 2, but not to the rest of the group, not to the byproducts, for example, or the degradation product of the pesticide, and then it will not be helpful. And one of the discussions that we had with the waterworks, they would like to measure it in the stream without introducing any additional chemicals, rather than divert of the stream out and measure it outside?
Well, I mean, beggars can't be choosers, so you have to do something. Maybe it'll work where you do have to divert just a little bit, and you could still do it on site in a portable lab, or maybe you will be able to do it in situ, but it would be a big step up than to not measure it at all, or measure it every 2 years.
Yeah,
Have it go out to a lab for a week. So, there might be some intermediate step that gets there faster.
Yeah, but that depends on, maybe it could be relevant for like highly contaminated area with like too many pesticides. Then it's a bigger problem that we cannot satisfy at the moment, or we cannot meet at the moment. So it could be that we divert the stream a bit, and then we play, or we modify the water sample chemically before we measure it, to give us an indication if the water contaminated at all or not, or if it's exceeding the detection limit, authority detection limit or not.
Another problem is, what happens before the water hits the water treatment plant. You may have glyphosate in it.
Yeah.
But after it goes through the water treatment plant, what if the chlorine or the other additives the treatment plant uses alter the structure of the glyphosate and make it different, or bind to it somehow, or create some kind of other compound that's more or less hazardous? Have you studied that? Because that may, mess up the measurements.
We didn't find a study or a research on that. To be honest with you, no, we don't have such kind of research in hand. But we know some of the pesticides are not stable. So once it hits the sunlight, for example, it degrades into separate products. So if let's say you are interested in or let's take a Roundup as an example, even though it's not scientifically true. But let's say it hits the sunlight and then it degrades into byproducts. Then if you are measuring only glyphosate, the byproducts will not be able, or will not be measurable with a traditional technique, because you didn't focus on them. And then they will slip through your hand and reach the customers. And they could be more toxic than the mother compound itself.
Yeah, exactly. That's what I'm saying. So it makes it very complicated,
Yes, it is. It is very complicated. And that's why most of the water producers, they would like even to measure it down in the ground, where it's the same situation that the pesticide has been kept for a while. It's dark, it's a certain temperature, and you're measuring there before you even pump it from the ground or from the river out. That will be more relevant.
It would? I think it would be more relevant right as it gets to a customer.
Yeah, but if you know what is there in the ground, then you apply the solution before actually it enters your treatment facility. So once you pump it immediately to a place where you treat it, and then you take it out for like further irrigation, add more oxygen, or filter it from particles or suspended particles, and send it away through the distribution network.
I see what you mean. They're thinking it may be easier to treat it before it even gets to the plant than afterwards.
Yes, exactly.
Okay. But they don't know, but it's a guess. But yeah, I understand.
Yeah.
Yeah, I mean, it's very complicated. Maybe some of these compounds adhere to small particles in the water, and then they provide a haven where they can hide, or maybe bacteria interact with them and change them. I mean, who knows?
Exactly.
Have you seen any studies that have studied, effluent from a water treatment plant and try to identify everything in it? Is that even possible?
No, not really. We didn't see such study. We look at waterworks and what they are producing and what is required for them. We didn't see like that intensive study where a person will say, I will measure every possible compound that do exist. No, actually, one of the incidents that popped up in the media a few months ago, it was a guy that studying at a university, and he was interested in a certain doing certain study, and then he went to a waterwork, collected a small sample, and then he was doing some measurements on it, and he discovered that a pesticide that is not even on the hot list, but it's way above the detection limit, the permissible limit. And then he had to report it, so the media got the story, and one waterwork after another started reporting that pesticide, even though nobody knew that it was there because it was banned in the 60s, because no one is doing that intensive study on the water.
Okay.
I would say it's a very...
You definitely have your work cut out for you, but it's a very important thing you're doing. So yes. I hope that you get a lot of help, and I hope it comes out and it's in use, because we all need it desperately,
Yeah, I would agree with that so much. Yeah.
So last question or two. What's your milestone? What's your goal for the next year or two? What would you love to have happen that would be an early result that would make you feel good?
Well, as we said, we are aiming to launch the product. And this summer, we will have some prototypes ready for the customers to test and give some feedback. And hopefully by the end of this year, we will release the first, let's call it beta version. And that's the most important milestone, is to have something in the market to prove and to show the scientific community and the waterworks as well, the customers, that actually the technology works as we are promising. That's the main goal that we are working towards, like for the past 3 years now. And we are reaching.
And what's the initial compound or compounds you want to test for?
We have a pesticide called pentazone. That's one. We have chloridazone. This is the second. And we have, the most importantly, is actually the Roundup, the glyphosate. That's like the hottest one that we are planning, and we have almost the sensor ready for it. Along with that, we have already a sensor ready for nitrate. That's also something that will be measured in the whole package. So when you receive this package, these 4 chemicals will be measured together, along with other like pH and temperature.
Okay. Very good. Very good. Well, what's the best way for people to learn more information about IPM and to contact you?
Well, we have our website. It's intpm.dk. We release a lot of news over there. And of course, as my affiliation as a PhD student, I'm still publishing some scientific articles, going to scientific conferences. So if someone interested, they can also follow, because in advance I put which conference I'm going to give a speech or a poster presentation. There are scientific articles always coming out, so they can read more about the achievement that we have done and what is the latest scientific findings that we have received. So they can also follow me on LinkedIn if they like.
That's great. Jafar Noori. Okay.
Yeah.
Well, Jafar, thank you for coming on the podcast. It's super important, your work you're doing, and I appreciate you being here.
Thanks, Richard. I really appreciate the time and for giving me the opportunity to share my story.
You're listening to the Future Tech Health Podcast with Richard Jacobs. Until I reached age 40, I never realized the obvious, that we all have medical issues, or we at least have a family member or close relation that has, or will have them in the future. Medicine and biological systems are the final frontier. Until we've conquered death, figured out how life began, cured cancer, and understood our purpose in the universe, there's a heck of a lot to talk about when it comes to our health. Future Tech Health means I'll be covering futuristic topics that are actually already in clinical trials, or even starting to appear on shelves or by prescription, or available for your own use. We dive deep into stem cells, CRISPR-Cas9, the science of sleep, epigenetics, medical testing, cancer, ketogenic diets, stem cells, aging, regenerative medicine, and more. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a serious medical problem. Remember, however, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you enjoyed the podcast, please listen, subscribe, like, and share it with friends. Thank you.